In this video, we will discuss about transmission lines and its primary constants. In the previous video, we have discussed about transmission lines and why do we need different types of cables when we change the different frequencies. So all these matters discussed in the previous videos. And in this video, we will discuss specifically what is primary constants. So there are four types of primary constants are there: resistor, inductors, capacitor, and inductance. You see, if you take any cable like this is a parallel cable and which consists of two conductor and which is separated with some insulating medium. It could be any insulating medium or it could be considered as a air medium. So they are separated with some insulating medium. This is a just a piece of transmission or parallel line cable. When you simply look at this physical structure, you cannot see any resistor, inductor, capacitor and conductance in this particular cable. Then where comes all these things, primary constants, into the account? And that's what we are going to discuss today. So if you consider two parallel line cable which is separated by air medium, and when you apply a signal to this particular transmission line, then the current will induce magnetic field around it, right? So that magnetic field which produces some inductance effects in the cable. I repeat, so when we apply a AC signal, that AC signal or time changing signal that produces or induces electromagnetism, a concept that is called inductors around this cable due to the magnetic field creation, and that is denoted as L in terms of inductor. And resistor, so if you consider any conducting material or insulating material, the resistivity of that particular material can be denoted as R is equal to rho L into A. And even if it is a conductor, when the length goes from a meter to kilometer, so for example if it is a transmission line cable that connects your TV station to your TV, or cable station to your TV, that takes around kilometers of length. When we have a coaxial cable or parallel line cable, in that case, length of the transmission line also play an important role. So as the length increases, even it is a conductor, then the resistor will be considered into the account, and that is where the resistor coming into the account. So the previous case we saw inductor, and this case resistor. The other two primary constants are capacitor and conductor. And you see, any two conducting material which are separated with some insulating medium, that is called capacitor. That gives you capacitance effect. So you will consider capacitor when we have a two conducting parallel line cable which is separated with some insulating medium. And though it is insulated perfectly or not perfectly, but practically there might be a little leakage current possible, and that leakage is called conductance. Why we call leakage as a conductance? Because resistor is nothing but the opposite of current, so we call it as a resistor. And leakage is nothing but your conductance, because conductance is inversely proportional or inverse of your resistor. So resistor resist and conductors leaks, so this is an opposite effect. So we consider conductance as a leakage format in this transmission line. So now you see, all together there are four types of primary constants available: resistor, inductor, capacitor and conductance. So resistor due to the length of the cable, inductors due to the magnetic field effect that induces inductance effect, and any two conducting medium which is separated with some insulating medium that gives you capacitance effect. And though it is insulated perfectly, there might be a little possible leakage current in this particular cable, that is considered as a conductance. And the most important thing is, this particular RLCG are not at one particular place, right? It is actually throughout the entire cable. If you consider this is the length of the cable, and you can see RLCG, and this will continue RLCG, RLCG, which means these primary constants are distributed along the transmission line. Okay, so that is why it is also called distributed parameters. Okay, so the distributed parameter nothing but your primary constants. So this is called primary constants, and RLCG are not at a particular place, it is a throughout the entire line. Okay, but if you consider a small piece of unit section like this, and that unit section will have one resistor, one inductor and one conductance and one capacitance, right? So RLCG or primarily occurs when you apply a signal to the transmission line, so it is called primary constant. And these constants are not at a particular place, it is a distributed parameters throughout the cable. So they are called distributed parameters. And if you consider any piece of unit section, that unit section should have all these four parameters in the cable. That is why it is called a unit section. And as I said, it is a distributed parameter because it has a continuous occupation in the location of the cable. Okay, and for analyzing this transmission line cable, we will not consider only this piece of unit section. We may consider as a T section or pi section. Okay, so that will be discussed in the upcoming lectures. So for this lecture, primary constants are 4 RLCG. They occur when you apply a signal, because physically if you see a cable, you will not see anything over here. Okay, so they all are hidden inside it. So when we apply a signal, all these four parameters coming into the account, and for analysis purpose also we will consider these primary constants. And the upcoming lecture will discuss secondary constants and its derivations. Thank you.